Welcome to Calculus, and if you're an AP student, then you know that derivatives are pretty much everywhere. But what happens if you find a function that's nested inside another function? And it might seem hard at first until you find out about one of the easiest methods to finding the derivative of these functions, the chain rule. Before I teach you though, it would really make my day if you subscribe so I can make you more videos. And on to the lesson. By now, you're probably a pro with the power rule. You see something like x squared and you're like, boom, it's 2x. But what happens when things get a little bit more tangled up? Let's look at this example. Here we have the function the square root of 2x plus 3. Notice anything different? That's right, we can see an outside and an inside function. The outside being the square root, and the inside being the 2x plus 3 that's trapped under the square root. Let's look at some more examples. For this function, the outside function is 3 over something squared. So the inside function must be the 5x minus 1 under the square. And of course trig can get involved, and this is an easy one. Sine of 2x, the outside must be sine, and the inside must be 2x. Okay, good job. Now that we've got that down, I can teach you how to find the derivative of these functions. And to do that, you're going to have to memorize yet another rule. The rule states that you must find the derivative of the outside function, multiply it times the inside function, and yet multiply it again times the derivative of the inside function. Alright, awesome, we know the rule, but trig is involved a lot in this unit, and if you want a 5 in the exam, then you're going to need to know the derivatives of the trig functions. Now, lucky for you, the first two derivatives are pretty easy to remember. Sine equals cosine, and cosine equals a negative sine. And you already know there's something coming. Tangent equals secant squared. And if you're just as confused as this guy, then don't worry, because that's exactly how I looked when I first saw these. Okay, so back to derivatives. We know that tangent is equal to secant squared. Well, guess what secant is equal to? Secant times tangent. And this same concept applies to the other trig functions. For example, on the other end of the spectrum, cotangent is equal to negative cosecant squared. And you'll never guess what cosecant is equal to. That's right, it's equal to negative cosecant times cotangent. And remember, this is the chain rule, so for each of the trig derivatives, you must also multiply times the derivative of the inside function. In this video, I'm just going to label it as u prime. Being able to draw these parallels makes memorizing math that much easier. And just like that, you know everything you need to find the derivative of one of these nested functions. So let's give one a try. Here we have cosecant 2x to the 4th power. Now, right off the bat, we can identify the 4th power as the outside function, and cosecant of 2x as the inside function. However, it's a little bit more complex than that because cosecant is also an outside function, particularly of the inside function 2x. Now that we know that, let's find the derivatives of each function. The first step is pretty easy. You just have to use the power rule to find the derivative of the outside function, x to the 4th, which turns out to be 4x to the 3rd. And as discussed before, the derivative of cosecant 2x would be negative cosecant 2x times cotangent 2x. And you know the last one, it's 2. Now the question is how do we turn all of these derivatives into one equation? Well, to do that, we need to use the chain rule. As you can see, we have the power of 4 that surrounds the entire function multiplied by the cosecant that is also multiplied by the 2x that is inside of it. So first we use the power rule to find the derivative of the power of 4. So to do that, we move the 4 up to the front and leave 3 as the exponent. And then don't forget the final step, we have to multiply by the derivatives of the inside functions. So that means the derivative of cosecant of 2x and 2x. So if you've been following what I've been saying, then the answer should be 4 cosecant to the 3rd 2x times negative cosecant 2x cotangent 2x multiplied by 2. And after simplifying, we should get a final answer of negative 8 cosecant to the 4th 2x times cotangent 2x. And with that, we are finally done with the chain rule. I appreciate you guys for watching, and I'll see you in the next one.